Hello. How is everybody doing today out there in the big ol' dang cloud?
So good.
So good. And
So good to be here back in the cloud with you, Austin.
it is amazing to be back in the cloud with you too, Katie. So, welcome to Deserted Island DevOps Summer Send Off for 2020. Um, I'm going to say a few words, then I'm going to introduce you to our wonderful Master of Ceremonies here. But first, I would be remiss to not make the following statement. Given this uncertain time in America, I think it's important that we remember that Black Lives Matter, trans rights are human rights, that there is power in a union, and if you have a problem with any of that, don't at me. With that said, I'd like to throw it over to Katy Farmer, who will be our Master of Ceremonies. What title would you like to give yourself this time?
I want to be the MC, the host, just the supreme hype man of DevOps speakers,
The
and
hostess with the
just a
mostest.
general fan of everyone here today.
Well,
So
take it
redo your
away.
intro and use all that.
Okay. Presenting the host with the most, the Master of Ceremonies, the Mistress of Ceremonies, whatever you want to call her, Katy Farmer.
Oh, thank you, Austin. It's such a delight to be here today again for Deserted Island DevOps. I am thrilled to be able to introduce our many speakers for today in our sort of summer kickoff. As Austin said, respect people. With that being said, we have a code of conduct. So look it up, abide by it. The link will be in the Discord. If you're not in our Discord, oh my gosh, why not? You could be there right now. And you can ask questions to the speakers as they're talking. And then at the end, I'll be reviewing the questions and asking them for you so that you can get some insight. You can also ask them in the Twitch chat if you're watching on Twitch. And gosh, I think those are all the main pieces of business. I'm just excited that we get to kick off today. So let me tell you a little bit about our very first speaker. Our first speaker is Fred Hebert. Today, talking about you reap what you code. And his charity is your local food bank. There'll be a link to a specific charity that Fred has given us, but also, think about your local food banks. Fred is a staff engineer on Postmates platform team, and he cares about things like learning from incidents, safely storing P2, scaling things up, and mentoring. All around winner. Everyone, please give a wide and warm welcome to Fred Hebert.
All right. Thanks, everyone. Do we have the slides show up or do we have to jiggle the wires this morning again here? All right. There we go. H marks. It's like a real conference. All right. So today I wanted to give a talk on this tendency we have as software developers and engineers to write code and deploy things that end up being huge pain to live with to an extent that we hadn't planned for. And in software, a pleasant surprise is writing for an hour without compiling once and then everything works. And a nasty surprise is that after 6 months, you find out that you've poisoned your entire life. So this presentation is really going to be a high-level thing. And I want to warn you that I'm going to go through some philosophical concerns at first, follow that up with research that has taken place in human factors and cognitive science and resilience engineering, and try to tie that up with broad advice that I think could be helpful to everyone when it comes to system thinking and designing things. So it may feel like a lot of stuff that is out there, but hopefully it's going to prove useful to people. So we start really with the philosophical stuff, and I'm going to talk a bit about Power and Equity, which is a text that's been written by Ivan Illich. And Ivan Illich is a wild-ass philosopher who hated modern medicine, didn't like mandatory education, and hated all sorts of things. He had this concept of an oppressive monopoly. And so if we look at societies that develop for foot traffic and cycling, like the islands we live on, you can generally use any means of transportation whatsoever and effectively manage to live and thrive there. So whether you live in a tent in a mansion, you can get around the same. Illich pointed out that cycling was innately fair because it does not require more energy than what is required as a baseline to operate. If you can walk, you can cycle, and cycling for the same energy input as walking is incredibly more efficient. Cars don't have that property. They are expensive, they require disproportionate amounts of energy compared to what a basic person has. So his suggestion was that all non-freight merchandise transport, whether by car, buses, trains, should be capped to a fixed percentage above the average speed of a cyclist. Which is based on the power a normal human body can produce on its own. And he suggested that we do that to prevent this. Essentially, he conceived, we as people conceived that cars would be a very interesting way to make our existing burdens easier. It created new freedoms, widened our access to goods and people. It was a better horse and a less exhausting bicycle. And so society would develop to embrace cars in its infrastructure and build itself around it. So rather than having a merchant bring goods to the town square, the milkman drop milk on the porch, and the market smaller and distributed closer to where it is convenient for people, it is now everyone's job to drive for each of the things while the stores go to where the land is cheap rather than where people are. And so when society develops with the car in mind, you need a car to be functional. In short, the cost of participating in society has gone up, and this is what an oppressive monopoly is specifically. So what about the software society, right? The key thing that Illich did was really ask the question another way. Rather than wondering like, what can I do with the car? He asked what would be the effect of them on the society if a majority of people had them, and then what effect would that have on the rest of people? And so the question to ask then is, do we have the equivalent in software? What are the things that we do and that we perceive increase our ability to do things, but turn out to actually end up costing a lot more just to participate? And so we see it kind of as a way of using network bandwidth. If you try to use a dial-up connection today, everything is more or less absolutely unworkable because we've raised the bar for everything, even the baseline information. But do we have the equivalent for the cognitive cost, the tooling, the documentation, and the procedures that we have? I don't have any clear answer to any of this. This is a question I like to ask myself a whole lot. But the key point, I think, is that the software and practices that we choose are not just something we do in a vacuum. They are part of an ecosystem, and they impact us back. And the idea is not that the software is trapped in with us, we're trapped in with the software. And so are we not ultimately just making our life worse for all of it? So when we write and adopt software to help ourselves, we might end up harming ourselves. And this is what I want to talk to because it speaks to our own sustainability. Fortunately, I'm going to leave the philosophical stuff for now, and I'm going to enter the bits of cognitive science. One of the really big papers around this entire area is Ironies of Automation by Bainbridge in '83. And I'm going to use the lessons that were in that paper with a bit more modern technology to show the point. And a lot of it is that, there's a clash between attention and practice happening when we automate things. So self-driving cars are a great example for that. If you look into established player in the automotive industry, they do lane tracking, blind spot detection, they handle parallel parking, but they don't do anything that fancy. If you look at high-tech company, right, Tesla, Waymo, Uber, they're working towards a full driving car, self-driving autopilots, and Tesla is like the most ambitious one or the most public one that we see in terms of actively being in production. A lot of the problems we see with that were already covered by Bainbridge in '83. So namely, the driver is no longer actively involved in driving and is shifted into the role of monitoring the car. The driver, despite no longer driving the car regardless, must be aware of everything the car is doing at all times. And when the car gets in a weird situation, it is expected that the driver takes control again. So the car handles the easy cases, but all the hard cases are left to the driver. And part of the risk there is twofold. People have limited attention for tasks that they are not involved in. And if you're not actively driving, it's going to be hard to be attentive for extended periods of time. And when you're only driving rarely, because most of the cases could be easy-ish, you risk being out of practice to handle the really, really hard cases. And so what's interesting is that really the airline industry deals with that usually by making up a lot of simulator hours for pilots. They're handling all the difficult areas like takeoff and landing. And there are still a lot of incidents in airlines where they discover that the handoff between the computer and the human is not going well. And so clearly, when we ignore the human component and its responsibilities, we might make the software worse for everyone. In general, I think a lot of these errors come from this point of view that what is called a fits model or habamaba, which means humans are better at and machines are better at. And so on the left side, we have the humans, which are better really at, being sensitive, perceptive beings capable of judgments. But the machines on the right are really, fast and terrible and reliable at what they do. And we still hear that kind of divide a whole lot today, right? It feels kind of right intuitively, but unfortunately, to be polite, this is baby's first automation design. It's intuitive, but it is wrong. It's comforting because it lets you know that you can predict the results easily, and it operates into what we see now, evaluating our current position, but really ignores the kind of emergent behavior and the things that happen outside of the predictions. So it's disconnected from the reality of human-machines interactions, and it frames choices as binary when they aren't, right? The human should be doing this or the machine should be doing that. And usually when it frames this binary decision, it does so while trying to push the human out of the system because they're smooshy and unreliable. So I think this is a significant explanation behind the ironies of automation, right? They're not trying to help the humans, they're trying to get rid of them. This is a patched version that comes really from the cognitive science. And they kind of reframed it instead into a human-computer relationship, which is a joint cognitive system. And that means that instead of thinking of humans and machines as unrelated things that must be used in distinct contexts for specific tasks, we should frame humans and computer as teammates working together. And teammates are going to do things like being predictable to each other, sharing a context and a language, being able to notice when their actions may impact others and adjust accordingly, communicate to establish the common ground that they have an idea of everyone's personal and shared objectives to be able to prioritize or deprioritize appropriately. So we must acknowledge that we're nowhere close to that, and the computers are not really teammates in the state of the art today. And since currently computers need us to keep realigning them all the time, but that we need them to process all the information in there, really we should think of our systems as a better way to help the human reorient the computer, like help us help it help us. And so one of the key things in there, in my opinion, is going to really be about helping diagnose the issues and forming and improving the mental models of humans trying to understand this tool that they have and keeps evolving in their hands. And so the question for me is, what makes a good mental model? How can we help people work with what we create? So this here isn't the City of London. It's a map of the City of London. It's just a model, and all the models are wrong, right? This map is very detailed. It has roads, it has rivers, it has train station, it has the names, the types of buildings that you have, lots of information. But it's a poor approximation. It doesn't tell me where the traffic is, if there is any road work, which areas could be dangerous, what's the smell in a given place, what's the weather like. This map doesn't give me that. In some contexts, though, this is going to be really good and useful, but this is still contextual. But the thing is that in general, we tend to want to have the best mental model available, and we might want to think of this as some sort of ideal mental model that we would like to have. In practice, our mental models are a bit more like this, which is a tourist map of London. And I'm pretty sure that there are not giant people as large as the Tate Modern in this map of London. But if I'm a tourist trying to go from, the House of Parliament to St. Paul's Cathedral, this map is a lot more helpful than this big one would be. And so this idea is that a mental model is really as good as its predictive power. If they let you make a decision or accomplish a task successfully, they are useful. And our minds are kind of clever in that they only build the models as complex as they need to be because we want the decisions made to be cheap to make. And so really this can help. And so there's a fun saying about how we validate mental models and understanding. And it's a philosophical thought that says that something does not exist until it's broken. Subjectively, you can be entirely content operating a system for a long time without ever knowing about entire aspects of it. And it's when something starts breaking down and going wrong that you realize that this component or this part of this behavior is in fact possible. And so since all of that is very subjective, experience-based, and can change over time, it's really, really difficult to control, or actually it's impossible to control a mental model. And we must take care to actually maintain them and share them and make sure that we test them from time to time. Otherwise, they're only going to be tested in very bad surprises. And so one simple step would be, how do we sync models? It would be easy if there were like just the dreams that we could upload and then everyone could visit them and understand exactly what we see, but we can't do that easily. And so, in a corporation, the things that we might do will be training, documentation, incident investigations, all help us understand that kind of stuff. Game days and chaos engineering are also excellent way to discover how our models might be broken and figure out other things. Someone just left the conference. Yeah. What's going on now? Well, we lost power. All right. We still see the slides anyway. So we can't just open what I think is a so-called glass pane and see everything at once when we work more individually. There's too much noise, too much information, too little structure. So seeing everything at once is only useful to the person who knows what to filter in and what to filter out. You can't easily form a mental model of everything at once. So to aid model formation in people, we should structure observability to tell a story. And most applications and components that we use and are easy to operate or that people rely on to be operable don't work by exposing their internals to you, right? If you're debugging the network on Linux or trying to figure out what goes on with a web server, they very rarely will tell you about line numbers and specific function calls and stuff like that. Instead, the thing that they're going to do is going to be far more based on letting you see and figure out the interactions that you have with the system. And really, this is probably the big principle to have there. How are we going to let people figure out their interactions without requiring of them to understand all the internals? The approach that I would have, and this is where the design here is important, is that I would mention that you want to log at the layer below which you want to debug. If I'm putting the tendency that we have is that we put all the observability probes at the app layer at the top there. And so we will put the metrics, the observability, the tracing, the logging is all done in our application at the top level. And when we want to figure out if something is wrong with part of the system, we usually start from the outer shell where we trace or we figure out the order of some request propagating through the system and figuring out for each component, is that behaving somewhat properly or not. I'm not looking to know how it's working internally. I'm looking whether the data I'm passing makes sense and the data I get out makes sense. And I'm looking into the interactions. The same is true when we look at really the drivers and stuff like that. The problem that we have, though, is that if I'm trying to debug the application, I can't really rely on the probes that are in the application because it might be misbehaving. And so the proper way to be doing that would be to have these probes in the framework. So if I have 50 endpoints on a given service, it would be kind of ludicrous to have to put observability probes in every one of these endpoints when I could just put one of them at the framework layer and cover all of them to understand what my application is doing, and am I using the framework in the proper way in the first place. And the big gotcha that we have is that when we have that observability only at the top level or at the lowest level, because the operating system is generally observable, and the only thing we have in the middle is our language runtime and our framework provides none of it, we have this sandwich of a black box, this black box sandwich where we have to cope for everything we can't see in the middle with what we can see at the edges. And so it's important to pick tooling and frameworks that let you tell that observability story and properly layer it. And the expected or desired end result is that you can skip around layers according to who you are, what's your experience, and what you're looking to do in the system. The support engineer debugging things doesn't have to have the exact same tools and point of view into the system as the engineer who wrote it. So really, that's big part, I think, in how we should be structuring things, and we generally do it in a very, very ad hoc manner. Another thing that can be helpful, I think, here would be regarding the logging practices that we have. Specifically, I think that there is a trust relationship between humans and a machine, and that trust needs to be maintained for things to work well. And one of the big things that we tend to do is ignore that. And if you ask anyone during incidents why they're looking at some metrics or different ones, they're going to tell you that they don't trust part of the system. And the best example for that is everything related to security or TLS. And I recall seeing log messages that were just saying, there's an issue, you are being hacked. Whereas the problem was just that the certificates had timed out. And really, like, this was an interpretation that the person writing the software did. They assumed that they made no mistake, that everything was right, and they tried to be helpful to dumb, smushy human who was trying to understand what the brilliant machine was doing. In fact, I think that the computer should only be logging facts, not interpretations. The human looking at the system is the one trying to put things together, and providing interpretations turns a fact-gathering expedition into a police investigation and questioning where all your witnesses are not reliable witnesses. So you want to log facts, not interpretations, and maintain that trust relationship. Structured logging is obviously better than regular text for that because you can make tools, build scripts, make programs over that, and using consistent naming makes it easier to skip around different parts of the system. There's this other thing, though, where we hit limits in the automation and things are just not going great. And really, this is a thing that ties to a concept called the law of requisite variety, which says that only complexity can control complexity. So if an agent can't represent all the possible states and circumstances around a thing it tries to control, it won't be able to control it all. And at some point, it's going to bleed over and just not work anymore. So unfortunately, the way that control is passed on to the next best thing is automation fails and cascades until humans come in and try to rescue them, because we do have more flexibility in modeling the world and understanding what goes on. So that gets to be problematic, though, because it's the same thing as when you're being told that you can't write the code as clever as you can because you have to be doubly clever to debug it. If you put very clever automation, but that is not handling all the cases when it comes to debugging it, you have to understand the system as it is, but you also have to understand the automation and the representation of the system as it is that was made by the automation to be able to understand where the automation was not being complete and then understand that. And so we have to keep in mind that adding automation to a system increases its net complexity in general in the event that anything goes wrong. Really, that's always kind of problematic because we try to make the common case easy, but we have to remember that we're just likely making the rare case even worse. One thing that we can do is to focus on handling the handoffs first. Because if we know and assume and accept that when automation reaches its limits, the thing that it does is bail out and ask a human to help it, we should start developing most of our automation based on that idea. Make that path working easily. Make it friendly, make it possible for the human to get a good understanding of what the state of the automation was at a given point in time so that you can figure out what it was doing and how to work around it and how to eventually guide it into doing the right thing. And once you've found that way to handle the handoffs properly, then it becomes kind of default backstop that is always present in there. And it's kind of the same thing as where you would use let it crash in your code, but doing it really with the automation and its failures that it would have. And that tends to possibly guide you in good directions. Another thing that I think is interesting is the curb cut effect. The curb cut effect comes from the ADA, the American Disabilities Act, which was enacted in the 50s, or I think in the 60s in the US, not American. But really this idea that to make sidewalks and streets accessible to people in wheelchairs, you would cut part of the curb, the one that touches the street, so that it would be easy to access and go around everywhere. And the thing that they found out, or that we found out collectively, is that even though you cut the curb for mostly the handicapped people, it's now easier for people carrying luggage, pushing strollers on skateboards or on bicycles to move around. Similar effects are found when you think of something like subtitles, which are put in place for people with hearing problems. But if you look at the raw number of users today, it's probably more students trying to learn a second or third language than people with actual hearing problems. Automatic doors that open when you step in front of them are also very useful for people carrying loads or just any kind of stuff in there. And it doesn't have to come up with this idea that, accessibility means dumbing down the things that you do. And I'm mentioning all of this because I think that thinking about accessibility and how we build things as a general principle is one of the things that can change the nasty negative surprises into pleasant emerging behavior, good surprises in them. And generally, accessibility is cheaper to build in than to retrofit. If we think of it, for example, with the web, accessibility lines up with better performance. If you think about device diversity, like how would you rethink your entire dashboard and monitoring and on-call thing if it were to be done 100% on a smartphone? And what would that enable people on regular computers to do? Same thing if you broaden your user base with different levels of expertise and everything like that. I worked with an engineer who used to work in a power station. And the thing that they had is that during the night where they were running on a short shift, they would generate an audio file that was all the monitoring metrics that they had and turn them into a kind of song that the engineer getting in the morning could listen to on fast forward to look for any anomalies that they had, right? So looking for these kinds of things can be helpful. If you prepare for your users of dashboards to be colorblind, would customizing colors be useful? And could that even be useful in the regular case that you have just to monitor specific metrics that tend to look weird over time? And so it's not just about doing more with less. It's requiring less to do more, as in let other people do more with less. The other thing there, I think, is that we have to keep in mind that complexity has to live somewhere. A thing that we try to do, especially software engineers, is to try to keep the code and the system, the technical part of the system, as simple as possible. And we tend to do that by finding underlying concepts, creating abstractions, and moving things outside of the code and into some kind of convention can be a part of it. And really what we tend to do is that the complexity, the essential or the existing complexity of the system in how you handle the problems always has to be around. Someone has to handle the thing. If you don't do it, your users have to do it. And if it's not in the code, it's your operators or the people understanding the code that have to do it. And so keeping that in mind, that there is this kind of fixed amount of complexity that moves around the organization in code and in people can help. Think of how people interact with the feature day to day. What do they do? How does it impact them or the network of people around them? How do they react to that? How do you approach software differently if you think that it's going to still be around in 5, 10, or 20 years when the people who wrote it have gone away? One of the things I like to think about is that instead of using military analogies of fights and battles, it's interesting to frame it in terms of gardens or agriculture, right? When we frame the discussions that we have in terms of an ecosystem and the people working collectively in that aspect of it, the way we approach solving problem can also change drastically, and that can be helpful in the long run. Finally, one of the things I want to mention about is this little thought framework I like when we're adopting new technology. And when we're adopting new technology, the thing we try to do, or that we tend to do, is to try it with the easy systems first. And then we say, oh, that's great. That's going to replace everything that we have. And then eventually we try to do it with everything, but it doesn't always work. Right. And so an approach that makes sense is to start with the easy stuff to prove that it's also workable for the basic cases. Try something really, really hard, because that would be the end point. The end game is to migrate the hardest thing that you've got. And if you have that distinction between replacing and adding, right? If you're not able to replace everything, consider that the new technology you're adopting is not replacing anything. It's something you add to your stack. It's going to change the approach you have in terms of teaching, in terms of maintenance, in pretty much every aspect that you have, so that you avoid the common trap of having a deprecated piece of technology with nothing to replace it that's still critical. The third one in there is diffusing, and I think this is something we do implicitly when, for example, we do DevOps, right? We took the ops responsibility and the dev responsibility, and instead of just having it like in different areas and small experts in operations, you end up making it everybody's responsibility to be aware of operations and stuff like that. And so that creates that diffusion where in some cases it's positive. You want everyone to be handling a task. But if you look at the way some people are handling containerization, right, it can be a bunch of operations people who no longer have to care about that, but all of the development teams now have to know how containers work and how to deploy them and how to work around that. And we haven't necessarily replaced or removed any of the needs about deployments. We've just taken it outside of the bottleneck it had and diffused it and sent it to everyone else. And so, yeah, having an easy way to early on the process figure out whether you're going to be replacing, adding, or diffusing will drastically change how you approach change at an organization level. And I think that it can help. This is all I had for today, and hopefully that was helpful and practical for you. Thanks.
It absolutely was. Oh my gosh. I loved that more than I even expected. Fred, thank you so much. So I specifically want to talk a little bit about, yeah, sit right there. I love it. The idea that accessibility is beneficial for everyone, because I think sometimes you're right. We think of accessibility as an afterthought, but what do you think about building, like, how can we encourage more people to think that accessibility really is for everyone? It's not, just for disabled folks. It's literally, it benefits all of society. How can we better reframe that in our work?
Wait, was this a question? I just stopped listening because I was finally done.
You did great.
I just got a big silence. I didn't realize what was going on.
No, that's
anymore.
okay. I mostly, I'll talk to myself for as long as you want. But I'm just curious, do you have any advice for like how we can, get people to bring on accessibility earlier in the process?
I think this entire industry kind of sucks at it from the interviewing process onwards. And for me, one of the basic thing is that instead of figuring out where's the bar and what's the level of expertise we're required to have, it's approaching everything in terms of what do we need to teach and train people to get to the places where we need them to be. And that approaches it from a human perspective in terms of doing the accessibility of the information, the kind of engineering levels that we have, the guidance we expect in the system. But I'm less able to talk, I think, to the technical accessibility where there are experts dealing with that. But device diversity is the most obvious one for me because I work in a terminal and I have this phone that would prevent me from lugging a computer around when on call, and that would be great. Right. And there are a few things like that where it can be obvious in hindsight that we could be doing better. I think it's easy to do better because there's so much terrible stuff right now.
Yeah, I think you're probably right about that. Everyone, please give a very warm round of applause to Fred Hebert. Hooray! My little Animal Crossing friend has lost her ability to celebrate. But don't worry, I'm doing it in my home. And it's always incredible to hear people tie in, one, not only that like accessibility matters and is beneficial for everyone, but also, yes, we should reframe problems from maybe something that has more negative connotations to this like ecosystem. What are we growing and teaching? And I think, Fred, I'll be thinking about that and telling lots of my coworkers to listen to your talk. So thank you very much. Okay, guess what? We have another speaker. Oh my gosh. Everybody, this might be my favorite intro of the day because it's not for a person so much as it is an idea. Next up, we have Simpsons Against DevOps. And what does that mean? Well, first I would check Twitter, maybe do some research there. But this is really not me introducing a person as much as it is a meme. And I'm just thrilled to be able to let this person really speak for themselves. They have chosen a charity, which is called Wires, which we will put up links for, which is doing amazing work rescuing and rehabilitating animals affected by the Australian bushfires. And definitely those services will be needed again as we move into summertime in the Southern Hemisphere. So, with almost no more ado, let me please introduce the mystery Simpsons Ops.
I forgot to unmute myself. All right. I'm coming.
This is the real mystery.
Technology.
I think everyone kind of missed the technical difficulties of a real conference. So we're here to bring that experience back to you. So let's try again. Everyone welcome Simpsons Ops.
Cool. Hi, everyone. I am Simpsons Ops. Some of you may remember me from my memes about Kubernetes, DNS, and even some about actual DevOps. So as much as I do enjoy talking about tech, today's talk isn't going to be about tech. And that being said, I don't think I can really compete with a lot of the really amazing things that we have lined up, especially Fred's talk that came up before me. That is not something that I will even try to compete with. Instead, you will get a arbitrary amount of time of shit posting from me in the form of a presentation. So what did happen was I couldn't really come up with a title for this talk, mostly because I don't actually know what this talk was going to be about. And even now, I'm still confused about what I'm meant to be talking about, which is fine. But you will get lots of interesting things along the way, though. So, one title that I did come up with that I was thinking about was How to Win Friends and Influence People by Overlaying Text on a Simpsons Image. I thought that name was okay. It had a good ring to it, but I don't think I've actually won any friends so far. If anything, I've made an enemy of Corey Quinn. Then I thought about making Simpsons memes relatable to DevOps for fun and not profit. This one was great too, though I wasn't entirely sold on this title. Number 3, the role of humor in DevOps. That was another idea that Austin floated by that I did think about. And it does make me sound, I think, a bit more important than I actually am. And it does make me sound like I do know what I'm talking about. The problem is that I have no clue what I'm actually talking about. So what I did settle with was Austin thought it would be cool if I did a talk. So here I am. All right, so I need to get one thing out of the way, and that is who I am definitely not. I think you can already tell by my accent. I'm not anyone of any importance. So who I am, or who we are just two friends that kind of got together and thought it would be fun to shitpost The Simpsons. So I'm on the left, I'm Jordan, and on the right is my friend Richard, or Rich, as he likes to be known. And we do spend a lot of our time researching and coming up with Simpsons memes that I hope you've been enjoying so far. So, ta-da! You must be incredibly underwhelmed right now.
Any questions?
I'm not done yet, though. So where are we from? I think you can all assume from my accent that I am from Australia. So both of us are from Australia. And I did just want to mention a couple of words that we do spell correctly. One is mum, color, organized without a Z or a Z. Favorite, which does have a U in it, and as well as labor. And I do want to just mention that it's been excruciating not being able to spell words properly on the Simpsons Ops account, because I've been trying my best to throw people off around who I actually am. So confirmed, not Matt Stratton. We also are home to the superior day, month, date format, as well as the metric system. So because I am in Australia, it is currently a bit past 2 in the morning. It is 2:42. So what I didn't think I'd be talking about today, well, what I didn't think I'd be doing at 2 in the morning was giving a talk about a meme account that I run via Animal Crossing. And is this the most millennial thing that I've ever done? Yes. Yes, it is actually the most millennial thing I think I could possibly do, apart from eating avo on toast. So, Austin Parker asked me to give a talk at the beginning of the month, and I pretty much got this message, which was, "Hello, mysterious meme purveyor. I have 2 questions for you. Do you have Animal Crossing, and would you be interested in giving a talk about creating Simpsons DevOps memes later in August?" Which I agreed to, and I don't think I've yet really understood what I was meant to be talking about. Austin thought it would be cool, so here I am. But the first thought I did have when I did get this message was, holy shit, it's that Animal Crossing guy. So I am happy to be here today. Small world. And yeah, I did spend a lot of time thinking about what to talk about.
I'm going to use all the power of my brain.
And I honestly couldn't come up with a single thing. So I'm just wasting time. But yeah, background about me. I'm not a thought lord. I do lack the discipline to regularly blog. One thing that did lead to this account was that I did fuck up and get a yearly subscription to Disney Plus, which, if any of you do have Disney Plus, has really nothing on it apart from The Simpsons to rewatch on a regular basis, which I have been doing. I do, however, enjoy making memes, and I think I really enjoy engaging with the community and seeing what everyone else has been coming up with as well, and just kind of engaging in all the conversation around what the actual account does and everything else. So how did we come up with this idea? I did run this message through at work one day, just kind of saying, hey, I've been planning to make a Simpsons Against DevOps account for the longest time. And all it took was a couple of people to say yes, and I started it up. But yeah, I think the main thing I think that I've kind of realized with this account is I haven't realized that 2020 sucks. But despite 2020 sucking so much so far, I really wanted to make memes that kind of let me distract myself from either coding or consuming media or the news or whatever it was, having a bit of fun, and hopefully making others happy as a byproduct of what I was actually doing. So who would have thought that a collective hatred of YAML would bring people together? Surprisingly, a lot of people did kind of bond together around a lot of things, but the 2 things I did notice they got offended by was either System D memes or anything to do with account takeovers. Which, by the way, if you are interested in taking over the account for a day, I am completely open to this. You don't need to have a 10K minimum follower cap, Matt, just saying. But yeah, so I was kind of going to go on a bit of a kind of philosophical journey and talk about the the role of memes and what memes actually mean in DevOps. But a lot of this has actually been things that I've realized in retrospect. So for the most part, it's just been a really fun form of introspection, and kind of being able to look at the community and what we've done and say, cool, let's really, like, I guess, make fun of the things we really don't like about what we do at the moment, or the things that do give us grief, and things that don't make us feel alone in our struggles every day, and just create a bit of relatability with what we do and hopefully start a few discussions. This makes me sound, though, like I do think this stuff through a lot more, which I don't. But it is also a critical form of self-expression. And we do get to ask a lot of questions this way and poke the community, and say things like, has DevOps just turned into Kubernetes at this point? And has it failed as a movement? Or is observability really just the 3 pillars, which I think Shelby will probably disagree with. So it is fun making things a lot more relatable and getting them involved. And I really have enjoyed seeing, I think, a lot of the cool stuff that people have been coming up with, and kind of sending through to the accounts as well. But if you are looking to start a meme account, I would probably give you a couple of these few headers. Number one is find your niche. Everyone has a passion about something, and it's relatively easy to kind of mix them together and create something like Simpsons Ops, which is a bit of a Frankenstein of different things, I guess. And consistency is key, and that's the number one thing. And I think a lot of DevRel people probably understand this one the best. But make sure you keep churning out content. Make sure you keep making things for people to look at and continue enjoying. So if you do want to kind of make sure it does take off, yeah, sometimes you're just not going to get any likes. And a lot of the times your memes will suck. And we've had memes that have sucked and I haven't been happy with them, but you just keep going and you make new stuff. Because it happens, I guess. And some people might not be happy with what you do make. Follow trends and know where to draw the line. I think probably the last one is most important for me is everything's funny until we do say something that is incredibly wrong and we offend a lot of people. So let's keep it about DevOps. Let's keep it about just kind of poking fun at the industry itself, and not actual people. I do want to thank a couple of people though. So this account really did take over after Meme Netties kind of retweeted once. Maddie and Corey were a pretty big one. I think being the chief shit posters that they are on the internet, people immediately saw this and were like, cool, all right, we're gonna pick this up and run with it. And we did have a bit of a retweet or an endorsement from Jeff Barr a while back, which was pretty cool to see as well. The cool thing that we have seen come out of this though is a whole bunch of different accounts, like a plethora of accounts kind of popping up. So one was Futurama Ops. We had Rock Ops, Seinfeld Ops, King of the Hills Ops, The Office Ops, Dario Against DevOps. Where have I gone? There we go. And these are all like, I'm not involved in any of these, but it's been great to see just everything pop up and seeing what the people are coming up with. So yeah, if you are thinking of making a meme account, please. I don't think I can consume too many memes in a day. I will do a bit of a shameless self-promotion, but I do run a monitoring meetup, which is on next Thursday, 6 p.m. Pacific time. And please donate to Wise. They do a lot of really good work here in Australia, and particularly after the bushfires that we had, they did help rescue and rehabilitate a lot of the koalas and native species that we do have here. Apart from that, though, that's really all I have. Even then, I feel like I've said more than I could possibly say about a meme account that I have. But thank you.
Yay! I'm really happy with this because I think that, I mean, you're being very, very humble, which is a good quality. But I think that it is a really interesting introspection to say that, like, you know, a little bit of a good meme account is a little bit of art right? And like in the same way that like if you were trying stand up or something, you might have to refine, but you have to do the same thing with the account, right?
Yeah.
And so I think that to find any success doing it means that you're like writing that line really well, and it also means you're probably hitting at the heart of problems the industry has.
Yeah, I do feel like we do kind of touch a nerve every now and then, and we will have a few kind of grumpy people. But I'm happy about it because
Yeah,
I think we are starting a few conversations.
I think that's what good. I even think that's what good comedy does, right? I think it makes you laugh, and then it makes you say like, oh, because like
Yeah,
we as an industry probably need to learn to laugh at ourselves a little bit more, in my opinion.
yeah. I think maybe taking ourselves a bit too seriously sometimes can be detrimental.
Yeah.
It is good to be able to make fun of ourselves, and I think we have had like good introspections into the industry before, from some movies, I guess,
Sure,
in
sure.
the past, and I think Silicon Valley to an extent was maybe a decent enough look into the tech world. But this itself, I think, for us to be able to look at DevOps as a whole and the direction we're actually headed is pretty fun.
And then, of course, to have just like the huge, like all of the catalog of The Simpsons to draw from.
Oh, there
right?
is so much to work with. Yeah.
There's so much. I also have Disney Plus, and I immediately was just like, I'm gonna watch The Simpsons. And and then I woke up and it was the pandemic. I'm not really sure what happened. Do you want to shout out your co-creator one more time, just so we make sure that they get attention to? Do you want to share a Twitter handle or anything?
There we are. Okay. That is
we'll
us.
Make sure it goes into
Richard.
the chat and stuff. But
yeah, no problem. Thanks again, everyone.
I thoroughly enjoyed it. I think there's a lot of value in memes. Everyone, please give a very warm round of applause to our friend Simpsons Ops.
Thank you.
Yay! That is a delight. I am so thrilled with the variety of talks that we're able to get on our Isla Vim, as it's called. And I think now we're heading into a short break. As you can see, we've had a little bit of island adventures. Sometimes when you do things in a video game, you just have to play by the video game's rules. And, maybe we'll take a break. We'll all go for a swim. We'll catch some jellyfish. And then we come back. We have 2 more amazing talks plus closing remarks. So give us just a few minutes. Again, try to visit the charities if you are able and give. And we'll be back shortly. Welcome back from the break, everybody. I hope you had a good break. We had a good break here on the island. You know, just like a little tropical retreat for 10 minutes. That's what everyone needs, I think. We talked a little bit just about how happy we were with the first two talks. We like to really make sure we compliment people until they're uncomfortable here. That's kind of our vibe. So that also means that our next two speakers better get ready for me to be nice to them. So without further ado, I do want to introduce our next speaker is Shelby Spees. She works at Honeycomb, and she's going to be talking to us about observability today, which I'm always a fan of. I always have things to learn about observability, and I find it to be really applicable to like every engineering job I have. So I'm excited. Her charity today is Charity Majors. Just kidding. It's actually bail funds. So support bail funds. And the link will be in the Discord and in the Twitch chat. And Shelby has been a professional software developer since 2015 in almost every domain, which basically means that she's learned how to do a little bit of everything. She's creative and she knows how to learn, which is why she's here to help us learn. And also, one thing I like about Shelby is that she likes her dog a lot, which I also do. It's just like karaoke and pit bulls. What else is better? Almost nothing. So everyone, please give a very warm welcome to Shelby Spees.
Hi, everybody. Thank you, Katie, so much. Yeah, and today we are talking about, I want to talk about observability for software teams. And this talk is basically meant to be the talk that I could have benefited from like 2 years ago. I joined Honeycomb this year as a developer advocate, and I'm really loving helping people level up their teams and help deliver more value. And so that's kind of the whole purpose of this whole observability thing. And let me talk about this control theory definition. This is the one that at Honeycomb we often pull from Wikipedia. Observability is a measure of how well the internal states of your system can be inferred from the knowledge of external outputs. And we care because we care about the health of our systems. Observability is a trait of your system. Like it's not binary. It's not like you either have observability or you don't. You can make your system more observable with some changes in your approach. And that's especially important nowadays because we're all running distributed systems. Even if you have the most like monolithic single everything's on one server app, you probably still rely on some external dependencies like API calls or even just like downloading and installing packages when you first spin up your service. So but a lot of us are running multiple services in production, and we've also gotten very good at building resilient systems. Actually, I want to give a round of applause to us because we build systems that, you know, you don't have to be paged because traffic goes up in any of our servers. We have auto remediation strategies like auto scaling and load balancing. If one server goes unhealthy, you just spin up another one. It does it automatically. We also have like duplication. We have failovers, we can do retries, and if you see a failure mode in production, you can go write a test for it to make sure it never happens again. So we end up with these failure modes that are emergent and really complex and very hard to anticipate, and they're very, very interesting, right? But interesting failures are also hard to debug. And things like which part of the app is performing poorly, or why are these users complaining but not others? Like only iPhone 11 users are complaining. How can we look at those people's experiences? And the thing is, your code has all of this context. It has all this data while it's running. It knows who's logged in as a user. It knows what service it's running on. It knows what methods it's inside of. It knows what SQL query it just ran. So why don't we try capturing that context? And so improving observability, good observability comes from how you interact with your system's telemetry data. And telemetry is this term we use, like telephone, metry, like thermometer or metrics. It just means remote measurement. You're collecting data over here and sending it over there to analyze it or monitor it or observe it. And so we can start improving our observability by improving our telemetry. In software, we use a few different kinds of telemetry, and this is where it's just a word for the things you already use, probably like pingdom, where you're just doing external probes, metrics like CloudWatch, StatsD, your dashboards like Datadog and New Relic, your flat logs, which you're just writing to your log files, or you might use a log aggregation service. A lot of people are exploring distributed tracing or even just single service tracing. And then also I want to talk about structured events. So the first one I mentioned, external probes, is very important, right? You ping your server every 5 minutes. Is it up? Is it up when I expect it to be up, or even like a more sophisticated approach where you're doing UI testing or API testing? Does it return the expected response? Like, you want to know when it's not up or when it's not healthy, but these external probes don't really give you a direction for debugging. It doesn't really tell you where to start looking in your investigation. And so then if you see like, oh, okay, I got a weird response here, you might start digging under the surface and look at metrics, your system metrics. And so here's a screenshot of our CloudWatch dashboard at Honeycomb on one of our front-end service. And so metrics tell you things. Fred did a really good job of explaining this earlier, where you can look at your system level, or your individual server level, or across servers, or on your ALB, how many 500s are you getting, how many active connections do you have, how much traffic, and is it like how many errors, sort of thing. But you end up with all of these disparate numbers that you're collecting that it's very hard to connect the dots and causal relationships. And so, you're looking at your wall of dashboards and you see this graph go up and you're looking for another graph that goes up, but is that actually related? You have to try and connect the dots later on. And so here I've used this graph from Spurious Correlations, which is a fantastic website. I highly recommend checking it out, where year over year, the number of letters in the winning word for the National Spelling Bee correlates very, very strongly with the number of people killed by venomous spiders. And at least in the US, I don't think that is a causal relationship, maybe in Australia. And the other thing about metrics is with system metrics, we're collecting things on the host or in the ALB, which is just another host, right? And we decide in advance what sort of questions we're asking. You can also do the same thing with business logic, but that starts to get really expensive because of because of cardinality. So if you want to say like, hey, let's measure the latency for each of these customers, well, you have a lot of customers. And so you have to collect each of those separately, and your monitoring services are going to charge you for each one of those customers that you're gathering these high cardinality metrics for. And so let me talk a little bit about this term cardinality, because we use it a lot, and I think it's a really, really important concept to sort of wrap our heads around. It took me a while to until I saw some examples. So some examples of low cardinality metrics are things like Booleans, true and false, only two possible values. Maybe in some programming languages you can have like a null or whatever, but usually there's not many possible values for your Boolean. Days of the week, you have 7 possible values. Maybe on a different planet, you have like 10 possible values, something like that. High cardinality metrics, on the other hand, are things like unique user IDs, which are infinitely growing. Build IDs are infinitely growing. Social security number, you probably have some sort of limit on that, but it's still quite a lot of social security numbers out there. RGB colors have like 16 million something possible values. And that's all cardinality is. It's just how many possible values can something have. And finally, metrics really only give you symptoms. They don't give you a direction when debugging, because we lose all that context. So I've totally done this before, where I'm looking at a graph and I'm like, okay, so the CPU utilization spiked. What was happening in the code? And I'm like trying to click on the graph to tell me what was happening. So your debugging approach is usually like you come up with a theory based on some past experience, and then you go try and find supporting evidence of that. And you'll usually look in your log files. You'll start grepping, tailing the logs, or going into your log aggregation service to start querying over there. but they only really help you when you know what to grep for. So if you're new to a team or you're new to a service, or you're on call for a service that you don't really maintain, you have to like go dig around in your run books. The other thing is that your log files, they don't really tell you about the interactions between services. You're just collecting what's going on for an individual service and then like trying to compile that together, and once again connecting the dots after the fact. So logging services are great for compliance, but not so much for debugging. And so if you're running a distributed system, you're probably interested in distributed traces, or if you haven't been before, you probably should be. I love distributed traces. They really, they were the first thing that was like, oh man, I've been looking for this. And a distributed trace is just another data structure where you have a collection of events that we call them spans, where each span has a start time and a duration, and there's a parent-child relationship. And so here's an example in Jaeger, which is an open source distributed tracing visualization tool, where we're placing an order and we're in the order service, and we charge the credit card, change the order status. We can see how long each of these methods or each of these events took place. And then we go over to the inventory service and we receive the event, update inventory, and prepare order manifest. And then we can see the overall duration of the entire request. And distributed tracing is really great because it answers the where question. Where in my code or where in my services are things slow or are things going badly? And so here we have this 1.243 second API call for exporting tickets. And so I can see exactly what happened underneath that, where we're doing this sequential MySQL query just like over and over and over. I think it's 31 times. And I may not know exactly what went into that, but now I know where to look in the code. Like, is this an us thing? Can we make this more, can we optimize these SQL queries to make them concurrent instead of sequential? Or is this a user error thing? And we can make our API a little bit more, protect people against having this happen. So now I want to talk about structured events. And I think of structured events as sort of this like object-oriented logging. We usually store events as like JSON blobs. And so you can create structured event data from even using your logging libraries. You can also use SDKs that hook into your programming language or your framework. And sort of, I'll talk a little bit more about automatic instrumentation to create structured events. Uh-oh, we lost somebody. And so the main difference between flat logs and structured, the main difference between flat logs and structured data is that flat logs get written eagerly. You can't keep track of state changes unless you want to add a whole bunch of extra detail that you then have to parse because it's all just like flat strings. Versus structured events, you can store all the data together within the context. And here's what that looks like in your code, where this is an image manipulation service where we can flip the image. And if we're receiving the image to flip and we get the content type and we want to log that, and then later on we want to find out whether or not we successfully flipped it, we have to do something like keep track of the request ID or the process ID or something so that we can connect these later on. And each of these gets written as you go. So if you have like 8 processes running on a box and those all get written to your log file, it's all like mixed up together. Versus the same code using events, you can collect all these attributes, all these fields like content type and how it's flipped horizontally, vertically, and then you can also attach whether it's successful or not and have that all clumped together. You write it at the end in this like nice, pretty package with a bow on it. And when you write your raw data in the structured format, it allows you to slice and dice things in interesting ways later on. And so from events, you can gather your metrics. You can gather your response codes over time. And so this isn't really the most interesting graph, but this is what our ALB response codes look like over time at Honeycomb. I think it was like a 2-hour time period. You can also get things like your error logs. And now we're adding additional context. We have the error log itself, we have the status code, and we also get the count, how many times it happens. And it's a lot easier to connect the dots here when all that data is structured together. And because we're just using arbitrary like JSON blobs, we can attach a start time and a duration and a parent-child relationship and generate a trace visualization. So we can do something like this, where all of these are just the same sort of structured events, but now I can see this active record SQL query that took like 4.951 seconds. Well, that's probably something worth looking into. So back to how do we improve observability? I said that good observability comes from how you interact with your system's telemetry data. And I started talking about like the quality and the sort of format that we're sending our data. And now I want to talk about interacting with that data. And so looking again at this is a Rails service, I can not only see that the SQL query took for almost 5 seconds, but I can see the exact query that was being run against the database. And so I actually went ahead and looked, and I was like, show me only where we're running this query. It ended up being way too narrow of a question. So I said, back up. Maybe this user is just having a really bad time. So I ran a query, and I created this heat map visualization to see the distribution of latency, basically like how fast or slow are SQL queries being run that have to do with this user. Are they especially popular? Are they sending us weird data or something? So we have at the bottom, we have these very, very fast events. And then we have at like sort of the 1.5, 1500 millisecond, 1.5 second level, we have another cluster of events. And at the 5 second level, we have another cluster of events. And this is like the sort of first few queries that we got, the actual SQL query being ran, is all of that stored together. And so, but this still doesn't really give me much of an answer. Like maybe let's back up a little bit again. Maybe I'm going down the wrong path. What if things are just slow? Let's just look at all the database queries that are slow. And so I did a query where I'm like, okay, let's look at queries that take longer than 2 seconds. This is another situation where it's like, I almost have too much data to know what to do. And this feedback loop is great because I can get fast responses, fast results for each of the questions that I have to ask. And I can learn more about the system as I'm asking questions about it. But what if the data could just tell me where to look, what to filter on? It turns out you can do exactly that. Here I've selected all the events that all the SQL queries that take longer than 2 seconds. And I said, hey, tell me what field or what attribute is different here, that maybe I can go and look in the code or look in our services to see what, whether that's worth fixing or if that's expected behavior. And so it's telling me, well, the article load is way more likely to be slow, or a slow event is way more likely to be an article load than a fast event. So as the engineer, you have the context, like, is this weird or is this expected? And this is where like all this is doing is like a diff. It's subtracting like, what's the difference between what's inside this selected area, this yellow area, versus what's outside of it. And so you don't need your machine learning model to tell you, oh, did I get kicked out? Oh no, someone else got kicked out. I apologize. I am missing from my podium. You as the engineer, you as a practitioner, have the context to be able to tell if these anomalies are important or not. And so if you wanted to train a machine learning model to tell you to do that, you would have to just train the machine learning model using your expertise. And so like, let's just skip all of that. And you can look at the data and say, okay, I get it. This is important. So just to recap, metrics go wide. They can tell you about trends over time. Logs and traces go deep. And with rich events, you can go wide and you can go deep. And you can shift between those views while holding on to the original context. And that context allows you to start asking new questions. Oh, my little thing got shifted. Anyway, you can have more insight. And so here I'm looking at, once again, the sort of the average latency P90, P95, and P99 on our different controllers. And this is a really common question to have. And so This way, you don't have to do a bunch of math up front. You can calculate your metrics using your raw data and keep the context. And so instead of going in and adding like stats timers in every single one of your controller, and then having to go back and remove them later on because it's so expensive, you just gather this all together, and you can start asking novel questions every time you have a concern. And so the kind of instrumentation we're putting on our code it's something you want to think about before you even start writing your code. We call this observability driven development. And it's about being intentional, right? Similar to test driven development, where you're like, not only do I want to know whether this code is working, but I want to write it in a way that makes it easy to change later on. I want it to be modular. And it's also easier to instrument your code if it's modular. And so thinking about all this ahead of time, and observing the code in production before you even write down the new feature, or before you even implement the new feature, it supports all these different goals: correctness, maintainability, reliability. Like, how do I know this code is going to be working right, and how can I see the impact on performance and reliability over time? And that allows us to also use similar tools in dev and prod. If you're watching and observing your code that you send from dev, you start to build that muscle memory, and it's a much tighter feedback loop. And then you're rolling out your small changes a little bit at a time, and you can immediately see it's so rewarding as developers to just see the impact of those changes. The active exploration is great for things like chaos experiments or A/B testing, where you learn more about your system and you start to share this knowledge. Like, hey, like send a link to your teammate. Like, did you know that our system does this? Like, and you start to spread that knowledge. And you also have smoother incident response because you have the muscle memory already there. You know how to start interacting with your data versus like some bespoke query language that you haven't used in 6 months, and then you have to like log in and try and remember how to find anything. And so if you want to get started with observability tooling, there are a lot of ways to do so. You can rewrite your logs to be structured. You can deploy an agent to collect different kinds of data. My favorite way is using packages that work with your code directly. Just adding a package to your project, starting to send from your development environment, and leaning on auto instrumentation so that you could just start to get insights right away. And so things like OpenTelemetry or Honeycomb's own Beelines have built-in auto instrumentation for popular frameworks like Spring or Rails to give you a lot of rich context and distributed tracing out of the box. And so this example I showed you earlier comes out of the box with Honeycomb instrumentation for our specific Rails integration. And OpenTelemetry is doing an awesome job of expanding this as well for a lot of frameworks. But I think it's really important to not stop there. Auto instrumentation doesn't know what's important to your business. You do. You as a developer, you know that. And so when you're writing your code, think about like, how do I know that I'm providing this service that I say I'm providing? How do I know about user impact? And so here I show an example where I have this method where I'm using a Twitter gem to gather tweets in 200 count batches from a specific user's timeline. And so I've added instrumentation to that where I can say like, hey, like, here's my get all tweets request. And let's see how it behaves during each of these 200 tweet batches that I'm getting. And it doesn't have to be a lot of work. It's not that much heavier than something like adding a log line. And so without having to do all this like, you're not moving mountains, and you can start having better conversations with your team because you have better quality data. And because you're doing custom instrumentation that's important related to like business, you can start talking the same language as people like your product owners and business analysts, and so they can start doing self-serve querying as well. If QA gets a complaint or your support team gets a complaint, like this customer says things are slow, they can just go in and be like, is it slow? And have a much better conversation about that. And then because people can do self-serve querying, more you have this better experience with knowledge transfer, and more people on their team feel the impact of their work, and you have this sort of shared ownership of production that I think it's really important for us as engineers and as software practitioners to feel that investment and the impact of our work. And that's something where, we've been insulated from production, especially developers get insulated from production for so long. This is the second half of the DevOps movement. We taught ops people how to code. Now let's teach devs how to live in production. So that's I talk very fast, my very fast overview of what is instrumentation and what is observability and how can we instrument our code better to have better observability. Please reach out. I'm on Twitter all the time. You can send me a love letter or, a normal letter at my work email. And you can also download these slides from honeycomb.io/Shelby. And I also hold office hours, so you can get on my calendar if you want to know what's the next step in your observability journey.
Hooray! That was, I learned a lot, and I think I used to have a job like that.
Awesome.
So I guess, Shelby, one question I have is like, what is like the first smallest step you can do to get started if you have like nothing?
If you have nothing, so I this isn't a honeycomb pitch, even though I just really like our logo. It's pretty, but we do have a self-serve. You don't have to have an account. You can go in and play with the tool and just interact with the data and see what it looks like. And so honeycomb.io/play is out there and free, and you can check it out. Another thing to do is if you have a side project, or even if your regular work project, you can try out instrumenting it a little bit with something like OpenTelemetry, something like Honeycomb's beelines, and just see what it looks like with the auto instrumentation. And it's I just think it's really cool when you start seeing traces show up and you start seeing those fields and you're like, whoa, like I can see the user ID and I can see like the the email address and all this stuff. And being able to break down on that is and so that part is like for a Rails integration, you add a gem, you add like a config and like a config block and add your API key, and then you're off to the races. So yeah.
Yeah, that's excellent. And I also totally commiserate with trying to find good graphs to show when you're making slides. You're like, I know this graph doesn't look exciting, but trust me. Story of every graph. All right. Well, I want to thank you so much, everyone. Warm round of applause for Shelby.
Thank you.
We do this seamless. Here we go. I stand. Oh, sometimes there's a real art to looking at the switch and not looking up at the screen in front of you where you think you're moving. And I'm like, why am I stuck on this tree? Oh, I'm walking away. That's okay. That happened while I was talking about it, and that's rude. Also my Switch, maybe I got too excited playing Tetris, but the keys don't work exactly like they used to. So now sometimes when I hit up, it goes up forever. But that happens. And also this dragonfly that's flying around us, I almost tried to catch it during Shelby's talk, but I didn't want to be too distracting, but this dragonfly needs to get out of my face. Okay. All right. We have another talk. We're all very excited about it. And let me introduce our next speaker. Our next speaker is Rich Burroughs. He is going to talk about what on-call does to us. And even when you just say that, I have feelings. So I know that there's going to be excellent things to learn. His charity is the Oregon Food Bank or your local food bank. It's always a good idea to give to your local food bank. And Rich is a senior developer advocate at Fire Hydrant, where he, mostly talks to people about on-call and incident response. He is the creator and host of the Cube Cuddle podcast and the founding organizer of DevOps Days Portland, one of my personal favorites. Is it because I love Portland? Is it because I love DevOps Days? Who knows? And he says he started using Linux when you had to install it from floppy disks. Oh, I could barely run it now. But everyone, please give a very warm welcome to Rich Burroughs.
All right, thank you. So we'll be talking today about what on-call does to us, looking at what science can tell us about the impact of being on call. Wanted to say first off that I attended Deserted Island DevOps the first time and had a blast, and I'm super happy to be here with you all. So yeah, I'm a senior developer advocate at Fire Hydrant. We make an incident response tool. You can find me on the Twitters. I'm at Rich Burroughs. And so the year was 1996, the year that Independence Day was released. It was a simpler time. I had gotten a job at an internet provider and gotten promoted to be a sysadmin. And then a little while later, my boss got me a pager. I was the only sysadmin at this company, and I was suddenly on call all of the time for a small number of Linux hosts. It was about 5 to 10 hosts. Honestly, I think I was probably pretty excited about this. I'd gotten this promotion, and now I had this extra responsibility of making sure the servers were up all the time. I think I thought it was pretty cool. So fast forward 20 years. I had worked at a number of other companies. I worked as a sysadmin at WebMD when the company was taking out Super Bowl ads, at a web hosting company, a payments company, a company with an email marketing platform, and then finally I was an SRE at Puppet in 2016. I'd been on call for most of that time in rotations of different sizes. Some of those were as small as 3 people, which by the way is too small for an on-call rotation, and some were as big as 10. For a while, I was actually at a company where my boss, instead of having us do weekly rotations, he had divided the day up into time slots. And the time slot I had was from 7 p.m. to midnight. So I was on call every day from 7 p.m. to midnight, and try having a life when that's the case. So my mental health had deteriorated some. I had started having very bad claustrophobia and panic attacks when I would board airplanes. The first time this happened, I was sitting there, we'd boarded, and I was, waiting to take off. And I had this debate in my head. I was saying to myself, hey, I could just go up to the flight attendant and tell them to let me off the plane, and they would have to let me off, right? So I ended up being diagnosed with generalized anxiety disorder. And I also have had bad episodes of depression where I'd basically be in bed for a week straight. Now, to be really clear, I'm not saying that all of this was from being on call. Other things were happening in my life that contributed to my anxiety and depression, and some of those go clear back to my childhood. But I also can't imagine that being on call for most of 20 years helped. My point is, we all have on-call stories. If you talk to anyone who's been on call, they can likely tell you about the pain they felt from it. Some of us talk about these things a lot. I've heard a lot of these stories from some of my peers as well. But this is all anecdotal. We all have biases, and we're unreliable narrators of our own lives. Meanwhile, there are psychologists and other scientists who've been studying the effect of being on call for decades. I think sometimes as people in tech, we think we know it all, and we ignore the work of people in other disciplines. We should definitely learn from them instead. So today we're going to look at some studies. I think psychological studies are a great way to identify things that are counterintuitive or areas where we're blind to our biases. Individual studies, though, are just one data point. So keep that in mind. Studies usually people try to duplicate them and build on them. So, just hearing about one study isn't necessarily the whole answer. And of course, I'm not a mental health professional, so keep that in mind during this talk. So before we get into the on-call specific studies, there are also a lot of studies about sleep. And of course, we all know that if you're on call after hours, that can lead to sleep deprivation. So there's a great talk from 2019 by a sleep scientist named Matt Walker. His team did a study where they had two groups of people, and one of these groups was sleep deprived, the other group slept normally. What they found is that the people in the sleep deprived group had a 40% learning deficit. Now, I've been woken up many times by PagerDuty in the middle of the night, and I've noticed some of the impacts of that. But honestly, I don't ever think I'd really considered the fact that in those times when I was sleep deprived, I just wasn't learning as well or remembering as many things. Some of the other things that Matt Walker mentions in his talk that can be caused by sleep deprivation, and this is a pretty scary list. Now let's talk about these on-call specific studies. And some things to consider when looking at these studies. Many of the studies look at people in other professions like doctors. In fact, when I was looking around, I didn't find a single one that was specifically about tech people. There may be some out there, but I didn't come across any. Some are focused on people who have to be on site, and some of them aren't. So a surgeon might have to go into the hospital to perform a surgery in the same way that we might have to go to a data center to put our hands on some hardware. And some of them use this phrase, extended work availability. Think of that as maybe a little bit broader than what we encounter in tech usually. You're not necessarily in a PagerDuty rotation, but you might, be on the hook for other things. One example would be a PR person, who's going to get a call if there's something bad that happens. All right, so the first study we're going to look at is called the relationship of on-call work with fatigue, work-home interference, and perceived performance difficulties from 2015. Now, the methodology here, they did a survey of Dutch employees. They started with a big group. They narrowed it down to a smaller sample. The subjects, were about in the age range and, gender mix maybe that we have in tech. And this focused on offsite on-call. So the findings here are pretty interesting. They suggest that it's employees' experience of being on call, especially the experience of stress due to the unpredictability rather than the amount of exposure. That's the issue. And WHI here stands for work-home interference. That's basically what it sounds like. It's a negative interaction between those two domains. So they found the issue is unpredictability, not the amount of exposure, or, in our case, the exposure would be what we'd call incidence. And they found that even a low amount of on-call hours a month and a low frequency of being called to work can relate to this increase in fatigue and work-home interference. They mentioned this concept of detachment. Psychological detachment refers to mentally disengaging from work and not thinking about work-related issues. A lack of a detachment relates to negative recovery-related outcomes such as fatigue, work-home interference, and emotional exhaustion. All right, study number 2, extended work availability and its relation with start of day mood and cortisol from 2016. They had 132 people from 13 organizations who completed surveys. The surveys were done 4 days while the people were on call and 4 days when they weren't. And a subset of 51 people provided morning cortisol levels. And what they found here is significant effects of work availability on the daily start of day mood and also the cortisol awakening response. So what is the cortisol awakening response? According to Wikipedia, it's an increase between 38 and 75% in cortisol levels peaking 30 to 45 minutes after awakening in the morning. Now, they don't actually know what the function of the cortisol awakening response is. But one hypothesis is that the cortisol rise after awakening may accompany an activation of prospective memory representations at awakening, enabling individuals' orientation about the self in time and space, as well as anticipation of demands of the upcoming day. So if that theory is true, it's kind of like resetting, right? Our mind and body kind of getting ready for the upcoming day. Now, this is definitely an impact to our bodies that I wouldn't have thought about or known about without digging into these studies. Now, if there was anything unclear about that study, just take a quick look at this table and it will explain everything for you. Now, the reason that I bring this up is that some of these studies are pretty hard to parse if you're not an academic. I'm not. I was a theater major in college and I dropped out. So I'm about as far from being academic as you could get. So if you run across one of these studies that's kind of hard, one of the things you can do is try to look for secondary sources. And I was able to do that in this case. There's a Scientific American article about this study. And what they mention again is that, the people marked lower moods in the morning after being on call. The possibility alone impeded recovery from work as the effects persisted even when no calls came. So this echoes the first study, right? So it's not necessarily the number of incidents. It's not the number of times necessarily that PagerDuty is calling you. Just the fact that you have this uncertainty that you might get pulled into something, has an impact on you. And again, they talked about mental detachment. So people who were able to detach from work, even while on call, were most likely to recoup their energies and avoid effects on mood and cortisol. So this also echoes the first study. All right, this third study is a little different. Understanding the differing impacts of on-call work for males and females results from an online survey in 2019. So they did an online survey of 228 subjects. They looked at sex differences related to on-call, not gender. I'm not crazy about the fact that this is binary, but it was an online survey. So who knows? I'm guessing that people, self-identified. It's not clear from looking at the study. But they say, quote, the results indicated that female respondents were more likely to be responsible for running their household. And they also mentioned that previous studies show, quote, women spend nearly twice as long as men on childcare and domestic duties. So let's look at a few questions from the study. How much does on-call work interfere with the sort of things you'd like to do in your leisure time? Now, as you can see, there's many more women or many more females in this case saying a lot or very much. How much does it interfere with the domestic things you have to do in your time off work? So this one shows a little bit less of an impact than the last question, but still more females saying that it impacts them somewhat or a lot. And how much does it interfere with the non-domestic things that you have to do in your time off work? Even less of an impact here, but still, impacting females more than males. I didn't know this. I'm single. I have no children. It all makes sense when I think about it, but it's not something I'd really considered a lot, that because of some people's life and family situation, that they're, having much more of an impact from being on call than I am as a single person. So to summarize the studies, the uncertainty of being on call is impactful, even if there are no incidents. Mental detachment can help with recovery. And being on call interferes more with some people's lives than others. Okay, so we know on call is hard, but what are some of the ways that we can improve it? One of those ways is improving incident response. So you can use incident response tooling for better communication and collaboration. You can improve your other tools that you use while you're troubleshooting incidents, like your observability tools. And learning from incidents is another thing that can help. And the folks in the resilience engineering community have a lot to say about how to do that. On-call training. I think we're not very good at this as an industry. So some things that you can do, you can train for your incident response roles like incident commander. So actually practicing the process itself and learning what the different roles need to do. You can do this through fire drills where you just kind of simulate an incident. I was at a shop when I was at Puppet, we actually did like tabletop RPG exercises where we had literally like a game master and roll dice and stuff. And you can do this with chaos engineering where you intentionally inject faults into your system and you can see, how you respond to those. You might do that in, even a test environment or something, when you're running these kind of drills. And I think a really big one, maybe the biggest, is changing how we alert. Of course, we want to make alerts actionable. We talk about that a lot in DevOps. You don't want to alert on 50% CPU usage, or really even 80%, right? It's not the amount that's the issue, but hopefully your system is built in a way where the fact that one server CPU spiking or one container using a lot of CPU isn't bringing everything down. So what we really want to do, I think, personally, is alert based on SLOs and error budgets. So these are SRE concepts if you're not familiar with them. But the idea is that you have this error budget, and instead of alerting on these individual components of the system having failures, you want to look at things from the user perspective, like we do with SLOs, and you want to alert when you're in danger of running through your error budget. If you're not familiar with how to do that, if some of this stuff is new for you, like SLIs and SLOs and error budgets, there's a really, really good book coming out very soon called Implementing Service Level Objectives by Alex Hidalgo. Alex is an expert in this area. I've talked to him some about the book and also read a few pre-release chapters from it. It's going to be really good. And I know that he's going to talk some about how to do this, on how to actually incorporate this into your alerting. So that book is available for Kindle now. I think the official release date is September 15th. So it's coming really soon. And last but not least, empathy. So I think it's so important to have each other's back when you're on call. The best on-call experiences were when I was on teams, where I really felt that other people on the team were looking out for me. And if you do that for each other, it helps a lot. Be proactive about that. If you see that somebody's having a tough week, don't wait for them to put their hand up and ask for help. Step in and pick up one of their shifts or something. So what can we do as individuals? Well, do ask for help if you need it, right? So like I said, we want to be proactive, but some, people have lives, they have other things going on. Don't wait for them to offer help. If you do need it, put your hand up. Look for ways to get that mental detachment that they talked about in a couple of those studies. When I read those studies and was thinking about mental detachment, one of the things that came to mind for me first was mindful meditation. Now, you might be a skeptic like me. When I first heard about mindful meditation, I was like, oh, that is just, spiritual stuff. I don't want anything to do with that. But the reality is that they've done a lot of studies around this, and they found that it really has an impact. And those studies include actually doing brain scans of people. So I think that's one thing to look for. There's actually a specific type of meditation that some meditation teachers use that's focused on self-compassion, called loving kindness meditation. And I think that is something that we can all use right now. And of course, therapy, and I know that not everybody is in a position where they're able to get therapy for some reasons, but if you can, please try to, not let there be a stigma associated with that for you. I've been in therapy for several years now. I find it super helpful. There's lots of different kinds of therapy. There have been studies that indicate that cognitive behavior therapy is very effective when it comes to dealing with things like anxiety and depression. In cognitive behavior therapy, you focus on the negative beliefs that you have that cause you to be anxious or depressed. I wanted to give a shout out to this book. My therapist recommended it to me. It's called When Panic Attacks by Dr. David Burns. It taught me a lot about anxiety, and also has a lot of cognitive behavior therapy exercises in it that you can use. He previously wrote a book called Feeling Good that's a little more focused on depression, but I think is a similar kind of thing, you know. And with his earlier book, they actually did studies that showed that people who used the book on their own without a therapist actually got better results than people who were on antidepressants. And they call that bibliotherapy. So if you are dealing with anxiety or depression, I would recommend reaching for one of his books too. Something that I've learned in my career is that in the end, you have to be your own advocate. No matter how much you like your team, your manager, your company, in the end, you have to look out for yourself. Those people might be great, but they have other concerns. They have their own lives. That may mean finding a new team or a new company if you're not able to improve the on-call experience where you are. In my case, it actually meant getting out of SRE. And I'm not recommending that everybody do that. But, I'd reached a point after so many years of being on call where I just knew that, I had to make a change. So again, look out for yourself. You have to make decisions to take care of yourself. And most of all, be kind to yourself. There's a great exercise from that book, When Panic Attacks, that I really love, where you imagine a friend who's in the same situation that you're in and what you would say to make them feel better. If you're like me, when you do that exercise, you're going to discover pretty quickly that you're much kinder to other people than you are to yourself. And so, please do find ways to be kind to yourself. It's really important. So thank you all for listening, and to the organizers. I really appreciate being able to speak here. I do work at Fire Hydrant. I'm happy to say that we're hiring, and would love to hear your feedback on the talk. If you have a chance, there's a short Google form. It just takes a few minutes, and it's anonymous. And that is it. Thank you very much.
That's amazing. Thank you, Rich. I really like this idea of the feedback form too, that's anonymous. That's really wonderful, especially given some of the sensitive material you cover.
I have to give credit to our UX designer, Jen, where I work, for that suggestion.
That's amazing. Yeah, I can fully concur. It's taking care of yourself and being thoughtful about the ways in which you do that, whether that's therapy or meditation, can be a real life changer for me too. And I think that we have to take care of ourselves. And when we're in positions where we can, then we should take care of other people on our teams too. Especially if you're in a manager or something position, right? Yeah.
I mean, and I should say too that it's not like I've solved all my problems, right? It's not like I meditated and read that book and suddenly I don't have anxiety. It's a process, but I do think those things help me cope a lot.
Yeah, I think that every tool is a good experiment to get to know yourself and what you need. And being on call is hard.
Yeah, for sure. And everybody's experiences with that is different, and it varies a lot from shop to shop.
Yeah, definitely. Thank you so much, Rich. Everyone, warm round of applause for Rich Burroughs.
Thank you.
Oh, yeah. I'm gonna share my own screen now for some closing thoughts. So if it sounds like I'm doing more than one thing at a time, that's because I am. I'm gonna stand here. I think I'm always really amazed at the quality of talks that we're able to get just by giving people a little bit of freedom. I think one of the nice things about this unconference or this island adventure is that the boundaries are lifted a little bit. So I think it's nice to be able to show off all the skills, right? From Shelby's like amazing lunch and learn to Rich's on call to just everything we've seen today. Someone left the island, so we'll get back to the Animal Crossing view in a second. But what I'm really doing here at the end of the day is just some closing thoughts. Austin and I have worked very hard on these Deserted Island events this year. We have loved doing them. And this is our summer closeout, but also our year closeout, because 2020 is a lot. But as we sort of move into the rest of the year, I wanted to make sure that you know that you're not alone just because we're not doing these anymore. I know can be a little silly, but we've built a little community here. And so I want you to know that we're still friends. We can still talk. We can still support each other. And these are just a couple of the ways I might like to do that. To remind you that, you are enough. Everything you're doing every day, even when it feels overwhelming and even when it feels unproductive, that was the best you could have done for that day. Be loud with your love. The things that you are excited about and passionate about, if it's monitoring, if it's the Simpsons, if it's, therapy, be loud about those things because it matters that we make change. Because the way that we are loud is a privilege. And being loud can help us make sure that other people's voices are heard too. Because this is a reminder that tech is not neutral. And I'm doing sort of a bad paraphrase here of Kim Creighton, who if you don't follow, you absolutely should. But the work that we do does not exist in a vacuum outside of politics and opinions and human rights. So keep that in mind with your friends and coworkers and the companies that you work for. We are making change every day, whether we know it or not. And it's important to pay attention to the ways in which we contribute to society as a whole. And because in tech, we have all of this beautiful privilege, we should stand up for others, especially when they're not in the room, especially when those voices aren't there. Make sure that they get space. Protect the most vulnerable people. Listen to them. And don't just, be quiet. Listen with your whole damn self. Respect their experiences and understand that you don't know someone else's experiences better than they do. I can only speak to this in the smallest way as a woman and a sort of underrepresented version in tech. Sometimes people just don't believe you. So here's my advice. Believe Black women. Those are the most vulnerable people a lot of the times. I think we have to make room to just let other people shine. We're great. I know everyone here today has made me so happy with all of their talks. I have learned and I have laughed and I've just had a great time. And I hope that by being able to introduce them to you all, that I have let them shine in a way that makes them feel like they matter. And if you have the opportunity to do that, you should absolutely try it. Because yes, we are moving forward in this wild year, but that doesn't mean that it's just about survival. It is, but if you have the ability, if you have the privilege, it's also about taking care of people. And if you're feeling lost and alone and you wish you had an island to visit, well, the good news is that we're still here and that we're still friends. You can always see me and Austin on the internet. You can find all of our speakers today on the internet. We're here for the long haul, regardless of whether we're holding virtual events or not. So my closing thoughts are just thank you to Austin for having this idea and putting it together and allowing me to be part of it. And thank you to all of our speakers for doing an amazing job today. And I'm looking forward to, hanging out on the internet.
Hello. Oh my gosh, Katie, you're gonna make me cry again.
Same.
Well, I look at Fred being fancy with the text. All right. I forgot to do this last time, and so this time I want us to have our big, the whole idea of this was. This started as a joke online and then has turned into just the most charming, amazing thing I think that I've ever been a part of in my entire life. And it wouldn't be possible without a few people that I want to thank. First and foremost, Katie, you are a joy to work with and an amazing human being. And this wouldn't be the same without you.
Thank you, Austin.
To all of our speakers who were able to make it, some of whom have spent way too much of the middle of the night or middle of the morning, early morning here. Thank you again. Thank you to our various employers who put up with our BS and allow us to volunteer our time producing these events. It's been it's fuck capitalism, but somebody paid for all of this stuff. So shout out to our employers, who you can find out pretty easily by finding us on Twitter, I'm sure. And with that, I think it's time that we all bid adieu to ELEVM for 2020. Don't worry, we're going to be back in 2021 in some format. It's going to be bigger, better, more amazing, more everything. Yeah, keep an eye on the internet and you will hear about it, I'm sure. So how's everyone feel about a big 1, 2, 3 and then call it a day?
Let's do it.
All right, so Pirate Poppers in 1, 2, 3 and go.
Yay!
Yay!
It's beautiful.
Everyone can speak up too. Say bye.
Bye.
Hi.
Hello.
Oh yes.
Hi,
Also,
so
thank you to
thank
Kat
you.
Cosgrove, who. Thank you.
Hanging
I'm
out.
sorry. I forgot about Kat. Thank you, Kat, for being part of our live studio audience.
No problem.
Shall we have a submission next time for your chance to be part of this live studio audience?
Yes. Brought to you by Tom Nook. All right. Bye, everybody.
all.
Thank you.